Balancing equations for radioactive decay. In this problem, it says fluorine 18 undergoes positron emission as shown below. They want us to enter the appropriate values for A prime, here, the mass number, Z prime, the atomic number, and X, the chemical symbol for X. So we want to find out what the element is, and we're going to look for its atomic number and the mass number that it goes. So first, we have to look for any balancing equations of radioactive decay. We have to find out what kind of radioactive decay it is and what's going on in that radioactive decay. So for positron emission, it's a proton that's breaking apart into a positive, into a positron, which is going to be the same mass as an electron but positively charged. And then it's also going to produce a neutron, and the neutron is going to stay in the nucleus. So what happens is when we use that proton, we're going to lose a proton. So that means this number is going to go from 9 to 8. And so Z prime is 8. And now that we know that it's 8, we know that atomic number 8 is going to reveal to us the chemical symbol for that. And when we look at the for that atom, because we can go to the periodic table and see what has an atomic number 8, and we know that's oxygen. So X is actually oxygen. Now we have to talk about the mass number. What happens to the mass number? Now that we've lost a proton, the mass number would go down by 1. It would become 17. But since we gain a neutron, we can add 1 again, and this remains the same at 18. So 18 would be A prime. So written out in a different way, 18F9 would become 18 oxygen with an atomic number of 8 plus the positron. And that is how you balance equations for radioactive decay.